Queen Victoria ruled over 1/4 of the Earth's population. She earned the title Grandmother of Europe by strategically marrying her 9 children into royal houses across the continent. But hidden in her cells was a genetic signature that tells a different story, one that reaches back 25,000 years to lands her empire would never conquer. When scientists finally decoded the Queen's DNA, they found something extraordinary. Her maternal lineage did not begin in England, Germany, or anywhere in Europe. It originated in West Asia, near present-day Syria, during the last Ice Age. And this discovery came not from Victoria herself, but from a murder investigation that changed history. In 1918, Bolshevik revolutionaries executed Tsar Nicholas II, his wife Alexandra, and their children in a basement in Ekaterinburg. For decades, the location of their remains stayed hidden. When investigators finally discovered a shallow grave in 1991, they faced a problem. How could they confirm these bones belonged to the Romanovs? The answer came from London. Prince Philip, the Duke of Edinburgh and future husband of Queen Elizabeth II, agreed to provide a DNA sample. Both Philip and the murdered Tsarina Alexandra shared a common ancestor through their maternal lines. That ancestor was Queen Victoria herself. Scientists extracted mitochondrial DNA from the skeletal remains found in Russia. Mitochondrial DNA passes exclusively from mother to child, unchanged through generations. If Alexandra's remains matched Prince Philip's mtDNA profile, investigators would have their confirmation. The results arrived with clarity that no document or family testimony could provide. The sequences matched perfectly. Both Philip and Alexandra carried identical genetic markers inherited from Queen Victoria's maternal line. But the DNA revealed something else entirely. If you're enjoying these historical discoveries, hit subscribe now. We explore the hidden stories behind famous people every week. And trust me, you don't want to miss what's coming next. Victoria's mitochondrial profile belonged to haplogroup H, specifically a subtype defined by mutations at positions 16,111T and 16,357C. This genetic signature allowed scientists to trace her maternal ancestry back thousands of years, far beyond any written record. Haplogroup H is the most common mitochondrial lineage in Europe today, present in roughly 40% of all European maternal lines. But it did not originate in Europe. According to multiple genetic studies published in academic journals, including Molecular Biology and Evolution, haplogroup H emerged between 20,000 and 25,000 years ago in West Asia. The most likely point of origin was the northeastern Mediterranean region, near what is now Syria and the northern Levant. From there, this maternal lineage expanded into the Near East and southern Caucasus between 33,000 and 26,000 years ago. As ancient populations migrated westward during and after the last glacial maximum, they carried this genetic signature with them. The lineage eventually reached Europe through 2 pathways: migrations from the Near East and later expansions from refugia in the Iberian Peninsula. This means Queen Victoria, the sovereign who presided over the British Empire at its absolute peak, carried DNA that connected her to ancient Near Eastern populations, to the lands between the Tigris and Euphrates, to the very cradle of human civilization. The implications reach beyond Victoria herself. Her maternal lineage can be traced backward through historical records to Anne of Bohemia and Hungary, who died in 1546. Every woman in this unbroken maternal chain carried the same mitochondrial signature. This includes major European royals spanning centuries, from various German principalities to the Russian imperial throne. Victoria's DNA also carried another secret, one with devastating consequences. The haemophilia gene that plagued European royal houses for generations first appeared in her bloodline. Scientists still debate whether this mutation arose spontaneously in Victoria herself or came from an unknown ancestor. Her son, Leopold, suffered terribly from the condition and died at 30 from blood loss following a fall. Two of Victoria's daughters became carriers, spreading the disease to the Spanish and Russian royal families. The suffering of Tsar Nicholas II's son, Alexei, from haemophilia contributed to the family's reliance on Rasputin and arguably weakened the dynasty before its final collapse. Yet DNA testing confirmed that the haemophilia mutation and Victoria's Asian maternal ancestry are separate genetic stories. The haemophilia came from either Victoria or her immediate ancestors through random mutation. Her maternal lineage, stretching back to West Asia, tells an older tale entirely. This distinction matters because mitochondrial DNA and nuclear DNA carry different information. The haplogroup H signature traces one thin thread of ancestry through mothers and grandmothers stretching back millennia. It represents just one of hundreds of ancestral lines converging in any individual. Still, the symbolic weight is considerable. The woman who represented British imperial power, who sat at the center of European royal networks, whose name defined an entire era of history, carried within her the genetic inheritance of ancient Syrian populations who lived during the Ice Age. Today, living descendants continue to carry Victoria's maternal signature. The specific mutations that defined her mtDNA still flow through royal bloodlines scattered across Europe. Scientists have used these genetic markers to confirm family relationships, identify remains, and reconstruct genealogical connections that documents alone could never prove. The broader story rewrites assumptions about European identity itself. Genetic research consistently demonstrates that modern European populations formed through multiple waves of migration from the Near East, the Caucasus, and the steppes of Central Asia. Victoria's DNA simply makes this abstract history personal. Queen Victoria married Prince Albert of Saxe-Coburg-Gotha in 1840. Together, they had 9 children who married into royal houses across Europe. Their descendants would sit on the thrones of Britain, Germany, Russia, Spain, Norway, Sweden, Greece, Romania, and beyond. When those descendants inherited Victoria's maternal DNA, they also inherited a connection to populations she likely never considered. The lands that gave rise to haplogroup H fell under Ottoman rule during Victoria's reign. The British Empire maintained complex relationships with these territories throughout the 19th century. Yet, 25,000 years before Victoria wore the crown, before agriculture, before written language, before cities, a woman living in the ancient Near East passed her mitochondrial DNA to her daughters. Those daughters had daughters. The chain continued unbroken through ice ages and warming periods, through the rise and fall of civilizations, through migrations across continents. And eventually, that genetic thread reached a woman born in Kensington Palace in 1819, who would rule the largest empire in human history. The science that revealed this connection barely existed during Victoria's lifetime. Mendel published his foundational work on inheritance in 1866. Watson and Crick would not describe the structure of DNA until 1953. The first mitochondrial DNA studies in human populations emerged only in the 1980s. Victoria herself believed in the importance of bloodlines. She wrote letters expressing concern about the health of royal families and the need for fresh genetic influence through strategic marriages. She could never have imagined that her own blood would one day reveal origins extending far beyond Europe to the ancient crossroads of human civilization in West Asia. That revelation came through murder victims and their surviving relatives, through Cold War-era scientific advances, through the careful comparison of genetic sequences across living and deceased individuals. What DNA revealed about Queen Victoria is not scandal or controversy. It is something more interesting, evidence that the foundations of European identity extend far deeper and reach far wider than traditional histories suggested. Every person of European descent with haplogroup H shares this ancient connection. Victoria simply stands as the most prominent example. If this video changed how you think about history and genetics, share it with someone who loves uncovering hidden truths. Subscribe now and comment below with which historical figure you'd like us to investigate next.